Okay. Um, I'm coming back to talk about the make file again. Let's take a look at the make file using the Emacs window. Okay, inside this make file, except the beginning, you have two, I call them macro, which is essentially defining the command I want to execute with a some kind of macro name so I can there's some good reason I need to do this, but I'm not going to explain this today. But what I want to show you is that essentially in a make file, I have a bunch of rule. In this case, I have 7 rule. All stackman.o, stack foo.o, stack bar.o, stack bus.o, and stack address.o, and then stack executable, and finally I have a clean rule. I have sorry, not 7. I have 8 rules. Okay, that's great. I have 8 rules. And then you can think about each of the rule has a 3 part. You have a target part, you have the dependency part, and you have the action part. So you for each of the rule, you have the 3 part. And the thing is that you can think about, okay, I have a bunch of rule in the make file, and they all have one or three of this target, dependency, and the action. And then you have to think about 2 questions, I guess. You will ask 2 questions is, how do I know that this bunch of rule that they actually put together is going to solve the problem about building a executable. And since I have a bunch of rules, well, how do I know, or how will the system trigger which rule at what time? So that's question number one. And question number two will ask is that, well, why does make file or make program really help me to do software development uh, versus the situation I don't use make, or I don't have make. And what do I gain by using make or make file? So we try to address this 2 issue for today. Okay, so first let's take a look at this. When you type make, that by default is actually going to in, invoke the first rule, which is called make all. So by the way, I do want to say this is convention that the first rule is always we call it make, is that you can either just type it uh, make, let me do a make clean. You can just type it make. It will try to trigger everything. Or you can say make all. Exactly the same. Means if you type only make, it will try to find the first rule in the make file and then to do the execution. But if you do specify all, which the all means the target all, so it will also find the rule that with this target all, and then which happened to be the first rule. So that's why if you type in make or make all, it should be the same. Let's actually make a little bit different. What happened? Let's try to play this a little bit. Let's try to change this to be make another rule. Let's make a 2 rule. Let's make a 2 rule. One is called all, and the second rule is also all. So does makefile allow you have a 2 rule that with the same target name? Okay. My guess is that it will complain saying that, hey, you have more than 1 rule for the same target, but let's try it. See, remember in programming, we always don't believe until we run the program. Say if I do this, oh, actually it will. Okay, okay, now I got it. You can have multiple rule, sorry, multiple rule with the same target, but it will always fire or trigger the first rule in the list with the specified target name. In this case, is actually just go there. But however, it doesn't have another rule called stack executable two. So that's why it's okay. That's actually coming back. Good to know. So I have to get rid of this. So the first rule it will trigger is all rule. And in the all rule, it will try to see, okay, I need to see the dependency list, which is the stack executable. Let me actually get rid of this. Okay, so the first rule that's actually default is the all rule. But when I process the first rule, I have to take a look at the dependency. And the dependency, which is the stack executable, which is stack executable is the target of another rule. So by specify the dependency element the same with the target name of another rule, that means whenever I want to execute this rule, it will trigger the other rule. So essentially, the second rule I will trigger under this chain reaction is going to be this particular rule with the target stack executable. Okay, so that's that. Hopefully you got that. You have the all rule, and now by triggering the all rule, you're going to triggering the other rule called stack executable. Okay, the same principle. So now I'm going to trigger execute the stack executable rule. I realize the first dependency element is stack underscore main.o, which will then trigger another rule because I do have a rule called stack underscore main.o. Okay, in this case, I'm actually on this rule. So that's why this is a rule number three. Well, then that's interesting because in the dependency list of stack main.o that you have stack main.c. Stack main.c, number one, it is not a target name. So there is a no rule with the target stack main.c. Similarly with stack 01.h, it doesn't have a target that's with the rule stack 01.h. So let me explain to you that when you have something in the dependency list, it should be either you have a rule with the same target as the name in the dependency list, or you actually have a file that's with the same name in the same directory. So in this case, both stack main.c and stack 01.h, they are files in the same directory. If I do this, you take a look at this in this directory, I do have stack main.c and I do have stack 01.h. So those two files are already there. I don't need, what I'm saying is that those two files you need in order to make stackman.o, those two files, I already have those two files in the same directory. I don't need another two rules with those two targets to generate those two files. Okay, that's what it's saying. So in other words, now let's go back to here. When I'm triggering rule number three, I will not trigger rule another two rules related to this two file because number one, it doesn't. I didn't give the rule, and number two, those files exist. Okay, so let's give a play a trick. If I do, let me first run the program first. Okay, if I now do a make clean, now you can see that even though I have those stack 01.h and stack main.c, it will still build everything correctly. However, now let me play around. I changed this stack 01 to stack 02. Let's change that to a different file. So now stack 02.h, number one, it doesn't have a target for stack 02.h, and the file stack 02.h doesn't exist. Okay, so it's neither the target nor exists. So now what should we do? If you specify make a file looks like it's going to give you error. If you do a make clean and then I do a make, you can see that it stopped. Why it stopped? It says that, okay, there is no rule to make a target stack 02.h, which is needed by the rule stack main.o. Okay, so essentially the make program is saying that, hey, you specify that you want to make stack main.o, but you also specify the dependency, but that dependency doesn't exist or doesn't have a rule to actually supporting that. Okay. Okay, let's change back. Stack one. Okay. So now you actually done with the rule number three. So what's the rule number three? Okay, this two file exists, so I will just basically compile this file. Remember, I use -c, which is compiling. And this is by doing this -c stackman.c, you will generate the stackman.o in this case. Okay, let's do one thing for you to see this particular rule. Ah, I know what I'm going to do. I'm going to do like this. So I have this program. Let's try to do make clean again. Okay, make clean again. I want to do a ls minus l stack man dot o. Okay, you see that I don't have the stack man dot o. So now what I can do, I can say make stack man .o. So essentially, I use this make program to directly invoke this rule. Okay, so remember I said if you only type make, I will always execute the first rule, but you can always give the target as the second argument in the make command, and it will actually trigger that rule. So now I can say make stack main.o. What happened? Oh, I didn't save it. Sorry. Yeah, now I save it. Now if I do make stack main.o, now it triggered this rule. It actually triggered this rule. CC is essentially GCC minus C, and then minus G is the C flag, and stack main.c. So I actually make stack main.o and trigger that rule, exactly that rule. The action is supposed to help me to generate that. So now I do ls minus l stack main dot o. Now you see that file exists. Earlier, I showed you the case about 1 minute ago. The file doesn't exist, but firing this particular rule, stack main.o, that it will generate that. Okay, so hope you get that. Now let's get back. So now I finish the stack main.o. Now I actually go to stack foo.o, which is the same principle. So the fourth rule is going to trigger, it is this rule, stack foo, and then number 5 is going to trigger is a stack bar, and number six is going to trigger is bus and stack, and rule number seven is going to trigger is a stack address.o. So by triggering rule number three to rule number seven, this is corresponding to the five dependency target that's actually specified in the rule number two, stack executable. So after you have done three, four, five, six, and seven, that means you actually already generate this 5.0 file. Then you're going to execute this particular file, this particular action, which is linking all this 5.0 file together, and then to come out with a stack executable final the output. Okay, so let's actually see how it really runs. Okay, kill it. Now what I want to do is make clean, then make. Okay, you can see that I first make a 5.0 file by this five individual rules, and then I'm actually going to generate the last line, which is putting all the dot file together, and then I generate the executable stack executable. Okay, now that's the way my first introduction to the makefile with such a rule with a separate compilation. Okay. Okay. Any question? I give you about maybe 5 to 10 seconds. You can ask the TA the question, and he can type it in your question in the chat box. Okay. Let's move on to the next slide. If you don't have a question, then I'm going to ask you some question. Let me see. You got this one. Okay. Now I actually done just look at that directory. I do a ls minus l. Okay, and then I got this uh things looks like this. But in particular, I want you to take a look this three line: stack executable, stack main.c, and stack main.o. Okay, okay, this is a bit tricky, but I want you to answer this question among yourself, okay? Because I cannot hear your answer. But in this case, I only focus on this three line: stack executable, stack main.c, stack main.o. Look at their timestamp. If at this moment I say make, either I say make all or make stack executable, do you think that when I do this is actually going to do something? Okay, when I say do something, let me actually tell you what do I mean by that. Let me bring back my window. Where's my window? Where's my terminal? Oh, my favorite terminal is here. Okay, so I have this section of file over here. If I say make stack executable, you see that it's basically say make stack executable is up to date. Or I say make all, it says nothing to be done for all. You can see that right now. It seems to me when I try to trigger this rule called make stack executable, or I try to trigger its parent rule, which is called make all, neither of them is doing anything. They basically just say, hey, you already done everything. Everything is up to date. You don't need to do that. Okay, that's the case over here in the PowerPoint file. Okay, in this file, I can tell you that because of its timestamp, that if you type it make all or you type it make stack executable, you're going to be you're not going to cause the make program to do anything because it will think that either the program stack executable is up to date, or the other way to say it is that there's nothing to be done. Okay. But now I want you to think about why is that case? Why in this particular screen that's there's nothing can be done. Take a look at the timestamp a little bit. Okay, the reason it won't work is let me actually tell you using this. So now let's actually compare stackman.o and stackman.c. Between these two stamp, which one is newer? So compare this two. This one is older, and this one is newer, right? Because this one was compiled today at 4:33, and this one was generated at 5:21, which is about 38 minutes. 38 minutes or 30 some 38 minutes, yeah. About 38 minutes after the stackman.c. So essentially, I mean, think about this. The timestamp about a file represent when the file was last modified or last created. So essentially, stackman.c was made its last change at 4:33. And after you make the last change, then at 5:21, you actually take that main.c, you generate a .o. So essentially, the .o file represent the most recent result from the stack main.c. So if .o is newer than .c, then you don't need to regenerate .o. So essentially, you save all the compilation. I mean, of course, you can still compile stack main.o, but you won't get anything better because your source code, which is already is actually older than your previous executable code. Okay, so that's one thing. But then if you take a look at this line, which is a stack executable, this is even newer than the .o and the .h file, .o and the .c file. So which means that the file was generated at 5:24, which is the newer timestamp compared to either the .c or .o. So in this case, the stack executable is already the newest based on the newest version of all the .c file. And therefore, the make program is smart to figure out based on the timestamp they will decide, hey, wait a minute, you don't need to do anything. And this actually save unnecessary computation in your system. I mean, you might not feel this is a big deal because, oh, you only got five files, what happened? But what happened if you have 5 million files? You try to generate a executable that's actually contain 5 million files together. And if you want to recompile every single one of them, it will take forever. But if you realize I really just need to compile this file where the .c file is actually newer than the .o file, not the other way around. Okay, so this is just trying to figure out which one has already the newest one, already up to date. You don't need to do anything. Okay, so I want to actually go to the second example. Now I change the timestamp a little bit. So the stackman.c and stackman.o is still the same relationship, but the .o is actually greater than the timestamp is newer than stackman.c. In this case, you don't need to execute the action that under stackman.o. However, the stack executable, the timestamp is older than the stackman.o, which means that stackman.o was produced after you produce the previous version of stack executable. Okay, in this case, what we should do, it will not trigger stackman.o, but it will trigger stack executable rule. That which means that, let me bring back the window. So in this case, it will not trigger this rule, stackman.o, in terms that it will not execute this line, but instead it will still trigger this one because the timestamp of stackman.o is newer than the target name, target timestamp, which is the stack executable itself. And therefore, when the dependency is newer than the target, then you have to execute, trigger this particular command, which is putting the all the DAO file together. So I want to summarize this a little bit. Is how do we know whether a rule should be the action part should be executed? The rule is that if any of the dependency is newer than the target, then you're going to execute the action part. Okay, so maybe I should write it down here. The rule is if any of the dependency list is newer than the target, it will be triggered if this is the rule. Okay. Okay. Now we're getting here. Now I want to give you the last one. The last one, now I further changed the timestamp such that the stackman.o is also newer than, sorry, stackman.o, yeah, stackman.o is older than stackman.c. That means you actually changed the program stackman.c. And now what you need to do is that you need to basically recompile stackman.o first, and then you need to generate stack executable the rule itself. Okay, so because the timestamp, let me show you example in my terminal. I will make. Okay, now this is I have already done everything is made, but I'm actually going to change the file stack. Okay, take a look at stackman .c. Stackman.c right now, it says it was changed at 4:33, right? So let's actually try to do one thing. Man.c. Okay, I just say I'm changing it. Okay, so I change it. If you now take a look at ls minus l, now you can see stack min.c has been updated to be 1149, which is much newer and is newer than both stack min.o and stack executable. Where's the stack executable? Yeah, stack executable is here, 1136, but the stack min.o, min.c is 1149. And also stackman.o is 1136. So stackman.c is the new. So now if I type a make, you see that it will trigger both of them. It will first trigger stackman.o the rule that's actually generates stackman.o, which is the first line. And then it will trigger the another rule, which is generate the minus o, which is the stack executable. Okay. All right. So hopefully, if the first time you are listening to the makefile, you never use makefile, so consider that is just a way to specify a bunch of rule, and then the make program will figure out which rule I should trigger based on the timestamp about that file. Okay, and how do you find out the timestamp? Okay, the make program they have a way to call system call. They can find the timestamp, but you can always use ls minus l to validate whether that particular timestamp order has been followed correctly. Okay. All right, I'm almost done. I guess I today I will not move on to the next topic. I will just finish the make file. Okay, the make file, let me try to summarize. It has a target, has a dependency list, and then it has an action. And the example looks like this. We went to this example, this two rule. Rule number one is about stack executable, about putting this 5.0 file linking together. And rule number two is basically the stackman.o, which is one of the component in the dependency list. And depending on the timestamp, that which one will be triggered, that the make program will figure that out very in a very smart way. So I avoid any kind of unnecessary compiling. Okay. So that's basically everything I want to talk about Makefile. And the example of Makefile, I already put it on the GitHub. Please take a look. Okay, I want to say something. Before the end of this week, please make sure that you have access to a Linux environment as I described on Monday about how do you using either WSL or using a MacBook. But I hope you can, number one, you have access to such environment. My requirement number two is that you will know how to go to the class GitHub page and download the whole thing as a zip file to your own local directory such that you can reproduce exactly what we have done in class, which in programming is important. You need to try to repeat what your instructor has have done in class and such that you kind of validate what you have learned, or you have some question, you can ask me when I go back to Taiwan. Okay, so I'm going to stop here, and I hope you have a good weekend. I'm sorry I cannot be there with you in person. I think I will just for Monday, for the coming Monday, I'm still on the airplane, so I'm going to just provide some kind of pre-recorded video and ask the TA to help you to for that session as well. Okay. All right. Good luck. And I hope everything going well with you. And see you on Monday. Not in person, but see you via YouTube or Zoom. Okay. Bye bye.